Welcome to my channel Learning Electronic Circuits. Here you can learn more about different electronic circuits, its working principles and the construction techniques. The multimeter. A multimeter is an electronic instrument which is used for taking various electronic measurements and readings. It is also called as a volt-ohm milliammeter or VOM. Multimeter is an essential handy tool for basic electronic fault finding and testing. It is a widely used device in electronics as well as electrical industry. A multimeter can take measurements such as voltage, current, resistance, continuity, transistor gain, etc. In some advanced multimeters, measurements such as capacitance, inductance, decibels, frequency, duty cycle, temperature, electric field, etc. can also be obtained. A modern multimeter uses an input circuitry to keep high input impedance at the testing leads so as not to disturb the impedance of the circuit which it is testing. There are two different types of multimeters, and they are the analog multimeter and the digital multimeter. The analog multimeter uses a moving pointer or moving coil galvanometer for showing measurements. The digital multimeter uses a 4-digit LED display for displaying the readings. Parts of a multimeter. The important parts of the multimeter are 1. Display section. It is a place where the measurement values are shown. It may be a moving pointer in an analog multimeter or a 4-digit LED display in a digital multimeter. 2. Selection knob. The selection knob is the part where the range selection or measurement type is chosen. 3. The ports. These are the sockets for connecting the probes. A multimeter usually has 3 ports. A COM port, which is a common port usually connected to the ground. It also has a milliamp volt-ohm port where milliampere current values, voltage readings and ohmic values of resistance is calculated. The one other port is the 10 amp port, which is where the current more than 200 milliamperes and up to 10 amperes is measured. 4. The probes. These are the 2 wire terminals used for connecting the components to the multimeter. The test probes which connect the components under test may be different types such as pointer probes, crocodile clips, retractable hooks, tweezer probes, etc. An on-off button sets the multimeter to on or off. The hold button helps to measure instantaneous or momentary values when the values are fluctuating. There is also a backlight button to highlight the display in dim or poor light environments. The multimeter unit is run by PP3 batteries or AAA batteries. The batteries can be replaced by opening the back cover of the multimeter and changing it with a new set of leak-proof batteries. For checking resistance, one of the terminals of the resistor must be lifted off from the circuit before connecting the leads, otherwise wrong reading will be displayed. Similar is the case for diode and continuity testing. Multimeters are mostly provided with fuses which can help prevent a current overload, thus damaging the multimeter. Replace it with another fuse of the correct current rating to prevent damage of the multimeter. The fuse box is fixed to the PCB, which can be accessed by opening the back cover of the multimeter. Safety precautions. It is safe to test a circuit using the multimeter when the circuit is disconnected from the power supply. It is also advisable to disconnect all power supply leads that is connected to the main supply. High value capacitors or charge retaining components must be discharged before testing the circuit to prevent high current discharge while testing, which can damage other components. There are multiple risks when sufficient precautions are not taken. There is risk to the operator. There can be damage to the circuit which is being tested or even damage to the multimeter. Hello friends, today we are going to learn about multimeters. I've got a multimeter here. It's a digital multimeter and it's a manual ranging one, and it's a very popular multimeter here in India. You can see it's a Mastec. We'll just go through the different parts of this multimeter. This is a display screen here, and another part of the device is the selection knob. Here you can see the selection knob. You can see the ranges, that is the voltage range. It has a DC voltage range from 0 volt to 600 volt, that is the DC voltage range. Then we have the AC voltage range, that is from 0 to 600. volt range, and this is the ampere range, I mean the current range, that is from 0 to 200 milliamp. It is shown here. This is the 0 to 200 milliamp section is here. This is the 10 ampere current position, and we have the resistor range here. It's shown in this part of the selection knob. This is the resistor ranges, that is from 0 to up to 2 megohm. So it is from 0 to 2 megohm. And we have the continuity position here, the continuity mode. I can check the continuity in this position range. We also got the transistor gain measurement position here, and we can insert there is a small slot that is shown here with 8 pins. It's used for placing the transistor. We have slots for NPN and PNP transistors. So these are the different values that we can measure using this multimeter. And we also got the ports. There are 3 different ports shown here. These are the ports or sockets where we are attaching the probes. There is a common port or socket, that is the sender, and we have the milliamp volt ohm socket. This socket is used for measuring milliampere currents and voltage and the resistance. These 3 values are checked using this socket. And here we also got another socket, that is a 10 ampere socket. It's only used for measuring current of up to 10 amperes, up to 10 amperes of current. So, and we also have this 2 probes, the black one and the red one. We have the black probe and the red probe. Black is the the common. We connect the black probe into the common socket. And now we also have got 2 buttons here. This hold button, just hold for holding random numbers that are showing, to hold to an instantaneous or momentary values of any random displayed values on the screen. And we also got a backlight button. This is a backlight button here. We also got the probe, and this is used to insert it into the socket. This part will be inserted into the socket, and this will be used to connect the terminals of components to measure its values. This is a pointer probe. So I will just go through how we can measure the different values or different ranges using this multimeter. Now let us check the voltage of a voltage source. Here we have the voltage source as the battery. These are the batteries that we have as the voltage source, and we have this jack of the probes. So we'll insert this black jack into the common port here like this, and then insert the red jack into the volt milliamp volt ohm position here, and we'll have to make sure this voltage sources are within the prescribed voltage range. Within this voltage range, it should come within the range that we are setting. So we have decided this voltage source is of a 9 volt. It's a 9 volt battery, so we are assuming that it does have a voltage of 9 volt. So we'll just change the voltage range to 20 volt range, and now we just position it to 20 volt range, and we just connect the terminals of this battery to the probe. I'm just connecting the one of the terminals in the black color probe, the negative probe, into the negative side of the probe, and connecting this into the positive, other terminal in the positive into the probe. So as you can see, it's showing 9.30 volt. So this battery is having 9.30 volt as the voltage rating. So this is how we'll be able to check the voltage voltage of a given voltage source. We'll also be able to, even if we change this polarity, we'll just change this polarity here and connect the other terminals of the battery. So we are just seeing here the negative number. You can see a negative sign along with the number. So it shows that the polarity has changed. So this shows that the polarity has changed, and because we have connected the wire terminals in the opposite direction. So in this case, the meter will show a negative polarity. So this is how we'll be able to make voltage readings using a multimeter. Now let us see how we can measure the continuity of a material. We'll have to change this selector knob to the continuity position. So this is the continuity position. Here you can see a small speaker-like thing, a horn or speaker-like symbol is also shown, because this position you also get a beep sound when you close this terminal. When you connect both this terminal, you'll be getting a beep sound. So this is how we'll be able to know the continuity. You'll be seeing it's a least digit. There will be a 1 that is displayed here. In this relay, you have a inductance, that is, there will be a coil inside, and also there is a connection, and that is single pole double throw type of connection here inside. So the terminals of the coil, we'll have to check whether it's connected or not, and that to keep. So this is an inductor position. and this seems to be the we can hear the buzzer. We'll be able to see the buzzer beeping. It shows that this is the relay connection, which is connected to on position. It is directly connected when the relay is on off. And we also have the other position where the other position where the relay is off. This is not connected, and this seems to be the inductor, the coil inside. The coil is showing 404 impedance. There is a impedance. There is 400 ohm impedance it's showing. Here we got a DC socket. It's a DC socket, and we'll also need to check whether the pins are correctly positioned, and which are the pins that are inside. So just to identify the connecting pins. So this way we'll be able to check each of the pins, whether there is any continuity between the pins, to check whether the socket is working. Now we'll just check a speaker. You can see a speaker, 8 ohm speaker. So this is showing 0.2 ohms resistance inside. It is showing the continuity. Here we have a switch. Here we have a switch that is a single pole double throw type of switch, and similarly we'll just connect this and check whether the switch terminals are the switch is operating normally. It should conduct in one position when you turn it in one direction. In a particular direction, it should show a continuity, and on the other side, on the other part, it should not show any conductivity. So it only conducts when it is in on position, and it won't there won't be any contact. There won't be any contact when you change it to the other direction. So this is how we'll be able to check a switch. Let us now check the diode. Here we will have to move the selector knob to the diode checking range. So we are right now we are just change the knob to the diode range. Now we'll connect a diode. We'll just place a diode here, and it's right now it is in the reverse. It's just placed in the reverse bias condition. So just change it over to the forward bias condition. Now this is showing, this is in forward bias condition. This is in the forward bias condition, and now this diode is conducting. Similarly, we can check the LEDs also. Here now it's in the reverse direction. It's in the reverse bias condition, so the LED is not glowing up. When you turn it to the other direction, now I can see the LED is glowing up. So this shows you'll be able to see the resistance. When you put it in the 20k kilo ohm resistance, you'll be able to see the forward resistance of the LED. That is, it's showing 15.78 kilo ohm. 15.778 kilo ohm. That is the forward resistance of this LED. So you can also see that the LED is glowing here. The LED glows up, showing the ohmic value there. Now we'll just learn how to check resistance. Here we've got a lot of different resistance values here, and we'll just connect take one of the resistance and just take one of the resistance and connect the probe. But actually this is beyond the value that is that we already set the value to 200 range. That is beyond this value of the resistor, so that we need to manually, ranging, we have to do it manually. It's not an auto ranging type of multimeter, so we should range it manually, and we have to change the range to different values to see the amount of resistance this is having. So it's actually it's around 1 mega ohm. It's around 1 mega ohm. It's near to 1 mega ohm. Here we have another resistance. This is another resistor. I just place it like this, and let's change the range to a lower value. Now this is showing 1.479. This actual value should be 1.5 ohm, 1.5 kilo ohm. It's showing it's near to 1.5 kilo ohm value. Now let us see how we will be able to measure DC current. So here we have a motor here with me, and we also have a source, the battery here, and we'll have to change the selection knob to the DC current range. I'm placing it in the 10 amp position. This is a 10 amp position. Now we need to change this plug, the socket here, to the 10 amp position. We'll have to change it to the 10 amp position, and then we'll connect the terminals here, and we'll just complete the circuit right now. Now it shows the motor is running, and here you can see the amperage, the ampere, the current that is consumed, which is 0.23 amp, showing 0.23 ampere of current that is being consumed by this motor. So this is how we are connecting it. So this is connected in series, it's not connected in parallel. Now we'll have to connect the terminals. We just place the multimeter in the 200 milliamp range. We'll connect the negative terminal of the multimeter here with the fan. We'll connect the negative terminal of the multimeter with this fan here and connect the positive terminal of the multimeter with the source here, the battery. So now we are seeing that the fan is running. This fan is turning, and you can see that it shows 105 milliamp. It's drawing around 105 milliamperes of current. So this way you'll have to connect it in series. You're connecting the negative terminal of the battery to the negative terminal of this motor or fan here, and the positive terminal of this will be connected to the negative terminal of the multimeter, that the probe. This will be connected to the positive side will be connected to the negative terminal of the multimeter probe, and the positive terminal of the probe will be connected to the positive terminal of the battery. So this is how you will be able to connect it. So now you can see that the current, you can see the current that will be shown in the display here. When you put resistance, the current draw will be higher. The drawing of the current will be higher. You can see it is coming around 1.6, and when it's freely running, it is the milliampere range is going down. How to test transistors? We'll be able to check the HFE of a transistor. That will be the transistor gain. For the transistor gain parameter, we will be able to check it with the multimeter. Here we have the NPN and PNP transistors slots given here, and it's already in the HFE mode. We will have to set the multimeter position to HFE mode. This is the HFE mode. You can see here, this is the HFE mode. We'll have to position the selector to the HFE mode. Then you need to find out the transistor, whether it's a PNP or NPN. We'll have to find out the transistor, whether the transistor belong to a PNP variety or a NPN type, as these are the two main types of transistor that are available. And here you can see the slots given for the PNP and the NPN varieties. First row, 4 slots are given for the NPN transistor. In the second row, 4 slots are there for the PNP transistor. Here you can see the emitter, collector, base, and emitter. These are the terminals where we need to align the transistors into the holes. We'll have to insert according to that. So first we'll have to understand from the data sheet, the type of transistor and the emitter base and collector terminals. So we'll have to find out that first, and then we'll have to insert this transistor into the terminals of the transistor into the holes. So here it's you're just inserting this terminus into the hole, and now you can see the reading that is showing as 56. This value is the the gain, a particular gain for that transistor. This is one type of transistor, which is it's slightly bigger than the other one. So this is an NPN transistor. So this has a gain around 56. This is the gain of the transistor. And similarly, we'll be able to insert some other transistors also. So this is also an NPN transistor. Just insert it, and we'll be able to know the power rating, amount of. Here you can see it's around 188. The transistor gain is around 188. So it's showing that showing around it just stops at 190. Now you can see another transistor, that is a PNP transistor, which showing a gain of 78. There's another PNP transistor that you inserted, and the reading shows 78. There is the gain for this transistor. Now we are going to check the AC voltage. For that we have a range in the AC voltage range, that is a 600 and 200 volt range. We have the domestic supply here, that is a 230 volt. So we should put the range into the 600 position, because it's beyond the 200 range. So we need to put it in the 600 range. So this is we are dealing with high voltage here, so we need to take caution. So we need to make sure that first we need to make sure that the position is in 600 range, into the AC volt 600 range. Then what we have to make sure that this is off. We'll insert the lead into the socket like this, and then we'll push the switch on. So now you can see the reading that is showing 230, is slightly higher, 234 volt, around 230 volt it's showing. So this is how we are able to measure the AC current values, AC voltage. This is how we'll be able to check the AC voltage range. So we need to make sure that everything is perfect, because we are dealing with high voltages here. So now we'll just push off this one and take this off. So this is how we'll be able to measure AC voltages. These are the line voltages.